Welcome to an overview of the Creating Landscape Irrigation Schedules training. This video will introduce you to the core concepts and key terminology necessary for creating efficient landscape irrigation schedules for healthy and beautiful landscapes. Over the next few minutes, we'll go over the learning objectives for this video, preview the Creating Landscape Irrigation Schedules training, and find out where to access the necessary tools for creating efficient landscape irrigation schedules. Remember to take the short quiz after watching the video. After viewing this video, you will be able to list the benefits of creating efficient landscape irrigation schedules, name the 3 important categories of information necessary to create landscape irrigation schedules, identify key irrigation scheduling terms, and locate tools and resources you used to create landscape irrigation schedules. First, let's recognize some of the important benefits of using irrigation water efficiently in the landscape. For landscape professionals, including gardeners and landscape contractors, the benefits include healthier plants, satisfied clients, job security, and higher pay for skilled work. For the client or homeowner, the benefits of efficient irrigation include lower water bills, healthier plants, and compliance with state and local water use laws. The environmental benefits of conserving precious and valuable water resources include reducing fertilizer and pesticide use, reducing pollution associated with runoff and deep percolation of water and chemical inputs, and reducing soil erosion. To create irrigation schedules, you need to know specific information about the area to be irrigated. The 3 main categories of information that you will need to be familiar with are the plant water needs, soil characteristics, and applied water. You will use this table to organize the information that you gather about a specific site. Next, you will go over the 3 categories of information in more details. First, you will calculate the plant water needs. In the category column, you'll determine if it is a high, moderate, low, or very low water use plant. Next, you will identify the monthly reference evapotranspiration, or ET, rate in your region of interest. The reference ET is a value that reflects the influence of local weather and climate on plant water use. Daily information and historical averages for many regions of the state are available through the California Irrigation Management Information System. Next, assign a plant factor number based on site-specific information, like sun exposure, wind exposure, and proximity to hardscapes. The plant water requirement is the calculated amount of water in inches needed by a plant based on reference ET data and the plant factor number. Calculating the plant water requirement will determine how much water the plant needs to be healthy in this specific situation. Along with the plant water needs, you should also be familiar with the soil characteristics of the irrigated landscape. First, use information gathered in the field or from online resources like the USDA Soil Texture Triangle to determine the soil texture. The soil texture classification directly informs the estimates of available water holding capacity and the infiltration rate of the soil. The available water holding capacity refers to the ability of the soil to retain water. The available water holding capacity will be expressed as inch of water per inch of soil. The infiltration rate is the dynamic rate at which irrigation water applied to the surface can move into the soil profile. The infiltration rate will be determined in inches per hour to know how quickly water penetrates and moves through the soil. The root zone depth refers to the estimated or observed root depth of the plant. This can be observed in the field with a soil probe or shovel, or can be estimated with a rooting depth table. The plant available water is the amount of water held within the root zone after gravitational drainage has ceased, minus the amount of water that adheres tightly to soil particles. The plant available water is calculated by multiplying the root zone depth by the available water holding capacity. The maximum allowable depletion is the percent of total plant available water that can be depleted from the active plant root zone before irrigation is applied. Select the appropriate maximum allowable depletion for your specific situation to determine how much water you are willing to allow be removed from the soil by the plants before the next irrigation. Now that you know more about the plant water needs and the soil characteristics, you'll need to gather some information about the irrigation system. Specifically, you want to know how is the water applied and how evenly is it applied across the irrigated area. The precipitation rate is the rate at which an irrigation system applies water and refers to the speed at which water is applied to the landscape. This can be measured in the field by collecting water in catch cans during an irrigation cycle, or it can be calculated using the product manufacturer's specifications along with emitter spacing and pattern. Distribution uniformity is the measure of the uniformity of applied irrigation water over an area and can be measured in the field or estimated. California state law requires that sprinkler system uniformity be at least 75% and drip system uniformity be at least 81%. Multiplying the DU by the plant water requirement will give you the irrigation water requirement. That is, how much water needs to be applied to satisfy the plant water needs while accounting for the inherent non-uniformity of the irrigation system. Using the information gathered about the plant water needs, soil characteristics, and applied water, you can use this simple 10-step process to create an efficient landscape irrigation schedule. During our next class, we'll go over this process and the irrigation scheduling tools provided on the HORT 58 Canvas webpage. Then, you will use this process to create landscape irrigation schedules for different scenarios in group learning activities. The 10-step landscape irrigation scheduling process is as follows. 1. Determine plant water requirements for the peak reference evapotranspiration month. 2. Determine irrigation water requirement for the peak reference evapotranspiration month. 3. Calculate zone run time for the peak reference evapotranspiration month. 4. Calculate plant available water. 5. Calculate allowable depletion. 6. Calculate irrigation days per period. 7. Calculate runtime per irrigation day. 8. Calculate maximum runtime per cycle. 9. Calculate number of cycles per day. And 10. Calculate runtimes for the remaining months. Several irrigation scheduling tools and resources are available to help guide and support you as you become more familiar with the process. On the HORT 58 Canvas webpage, you will find the Creating Landscape Irrigation Schedules worksheet. Use this tool to enter site-specific data and to perform complex calculations. Watch the brief How to Use the Creating Landscape Irrigation Schedule Excel worksheet tutorial to help guide your use of the worksheet. The narrated PowerPoint slide is similar to the slideshow that will be presented during the lecture in class. And the Creating Landscape Irrigation Schedules job aid provides step-by-step instructions for creating landscape irrigation schedules. Useful online resources include the Water Use Classification of Landscape Species, where you'll find information about plant water categories and different climate regions in California. The Model Water Efficient Landscape Ordinance is the California law that provides information about planning, designing, installing, and maintaining water-efficient landscapes and includes a reference evapotranspiration table with data for multiple regions in California. The USDA soil texture triangle can be used to approximate the soil's response to environmental and management conditions. For irrigation scheduling purposes, it can be used to estimate the infiltration rate and the available water holding capacity of a soil. Links to irrigation scheduling resources are available on the HORT 58 Canvas webpage. After viewing this video, click on the link below to test your knowledge. Thank you for watching.